the double-slit experiment, science's version of what the hell just happened. It starts out innocent enough. Way back in 1801, a guy named Thomas Young, who was clearly too curious for his own good, wanted to know what light really is. A wave? A particle? A divine sneeze? Nobody knew, so he did what any of us would do. He grabbed a candle, made a cardboard cutout, and pointed it at a wall. Okay, I'm simplifying, but the idea was this: shoot some light through two narrow slits like a high-stakes game of photon darts, and see what pattern shows up on the wall behind it. If light were just particles, little ping-pong balls of pure sunshine, you'd expect two straight lines to appear on the wall, one for each slit. Simple, predictable. But that's not what happened. Instead, the light made this wavy, stripy interference pattern, like a zebra made of science, or a barcode for God's secrets. So, light is a wave. Hooray! Put it on a t-shirt. Science rules. But wait, the plot thickens like pudding in a microwave. Over 100 years later, scientists upgraded the experiment. Now, instead of using a light beam, they fired one photon at a time through the slits, like speed dating for particles. And weirdly, over time, the same wavy interference pattern emerged. Hold on, how's that possible? Each photon was going through the experiment alone. It's like if you threw one person at a time into a rave, and they still managed to form a conga line. So they thought, maybe the photon is splitting in two and going through both slits at once. That's right. Quantum physics said, screw your common sense, this particle is doing a double act. Now here's where the universe gets cheeky. Scientists wanted to catch the photon in the act. Let's see which slit it goes through, they said, probably rubbing their hands like cartoon villains. So they set up detectors at the slits to observe the photon's path. But the moment they did that, boom. No more interference pattern, just two sad little lines on the wall, like a frowny face drawn by a disappointed particle. Let me make this clear. Just watching the photon changed what it did. Before, it acted like a wave. But once it knew it was being watched, it buttoned up its lab coat and became a respectable little particle, like it was trying to pass a sobriety test. So now we're stuck with this deeply uncomfortable truth. Observation changes reality. Or, as physicists call it, wave function collapse, which sounds like something you'd experience after eating expired sushi. And it doesn't stop with light. They've done this with electrons, atoms, even molecules. And they all get weird when you stare at them, which is something I also say about my neighbors. Now some say, it's not really observation, it's measurement. Okay, fine. So the universe doesn't care if a human sees it. It just doesn't like being measured, like your weight at the doctor's office. So let's take stock here. Light behaves like a wave when no one's watching. It behaves like a particle when someone is. And the act of observation itself changes the outcome. You might be thinking, that sounds like a metaphor for my dating life, and you'd be right. But it's also one of the most famous mysteries in quantum mechanics. There are theories. Oh, there are so many theories. Some say particles exist in a fuzzy cloud of probabilities until they're observed, and then they choose one path. That's called the Copenhagen interpretation. And no, it doesn't come with a pastry. Others say every possibility plays out in a parallel universe. That's right. Every time a photon picks a slit, another universe branches off where it picked the other one. Infinite U's, infinite bad haircuts. And then there are those who think this whole thing is proof we're living in a simulation. That the universe only renders itself when we're looking, like a video game with really good graphics but terrible AI. But the truth is, no one actually knows what's going on, and scientists hate that. They want the universe to follow rules, not act like a drunk raccoon in a lab coat. So what do we take away from all this? Well, if reality only decides what it is when it's being watched, maybe it's not as solid as we thought. Maybe we're all just probabilities until someone notices us, which means you can stop going to the gym. If no one observes your muffin top, it doesn't collapse into reality. The double-slit experiment tells us that the universe is not only stranger than we imagine, it's stranger than we can imagine. And somewhere out there, a lonely photon is trying to figure out if it's being watched, or if it's free to dance like nobody's measuring. Good luck, little guy. You do you.